Welcome to the future. I'm Dr. Lewney, that is my real name. If you're born with a name like that, you've got to get a PhD, right? It's kind of rude not to. So my PhD is in acoustics, and I'm now a senior patent examiner here at the Intellectual Property Office. And I'm the guy who says whether it's been done before. So if you've got an invention in telecoms or voice recognition, I say whether it's been done before and whether you can kind of own that idea. So I get to see really cool ideas before anyone else does. And that puts me in a good position to hopefully be able to predict what kind of technology might become significant in future. So here we are, 2021, right? The future of so many movies and books of the 20th century, and we're able to see how well their predictions stood up. So 1968, the movie 2001, A Space Odyssey, tried to predict the future just at the turn of the millennium. And they did okay in some ways, but were enormously ambitious and over-ambitious in other ways. We're not living on the moon, let alone anywhere near Jupiter. But they did get iPads right. The big spaceships and all of that, that was hugely over-ambitious, but the actual information technology is where the progress really did come about. And then 1989, Marty McFly travelled to the future of 2015 in Back to the Future 2. Again, they got a few things right in terms of the information technology and some of the things in a home, but again, the transport, the big things like flying cars and hoverboards. Hoverboards have still got wheels. And then in 1980, I read this book as a child. This is by Magnus Pyke, who was the Brian Cox telescientist of the time. He used to shake his arms around all over the place. And he tried to predict in 1980 the world of 2030, which is only 9 years away from us. So we can see kind of how he's getting on. And he made a number of predictions. Firstly, he said, you might be living in a house made of plastic. Well, we've already got houses made of plastic. They're called caravans. He also said, right, you might be traveling in a train at 22,000 kilometers an hour. Other side of the world in an hour, faster than 13 times the speed of sound. That's definitely a bit ambitious. I'm quite happy if my train's going faster than the speed of stopped. But this is where he gets it right again. He's got, in your wall-sized television, you could order the groceries using the silicon chip in your home computer. Even then, he's being a little unambitious in terms of the progress that's actually happened. He was still thinking of like a big computer unit in your house. He had no idea that we'd be doing it on basically Star Trek communicators. So people have been doing this all throughout history, trying to predict the future and not actually doing it all that well. One of the most famous guys, who's supposed to be one of the best, is Nostradamus, this guy. And this is supposed to be one of his best predictions because people think it sounds like World War II, especially the name of this river, the Hister, which sounds like Hitler. Come on, it's just a really poetic guess, isn't it, that you just fill in hindsight. So we have trouble predicting everyday events, like real trouble. Like we can't even predict next week's weather very well. But there are some things that we can predict incredibly well, even decades in advance. I'm talking about a solar eclipse, where the moon passes in front of the sun and blots it out for a specific number of seconds in a specific town decades in advance. How come we can predict that, but we can't predict everyday events? It turns out there's only certain kinds of system which you can actually predict accurately in the manner of solar eclipses. This is my favourite animation of the solar system, right? We're used to seeing it as the sun still in the middle with the planets moving around it. But if you think about it, the sun is moving around the galaxy. So the path of the planets are these beautiful spirals instead. Incidentally, this is why I think we'll never achieve time travel, because if you think about it, you're going to need to know exactly where the Earth was or will be. If you only move in time, you're going to end up in empty space. Even if you get it almost right, a tiny error, you're going to end up in the sky or underground, which seems pretty fatal. But this system is a kind of unique system. It's incredibly stable. We say it's in equilibrium, and that does allow us to make very specific predictions, even long time scales ahead. Most real systems are much more complicated, right? So here we've got a pendulum. This is a simple pendulum. If I let it go, yeah, I could predict exactly where the little red light was with great accuracy, even a few seconds in advance. What happens when I make a little hinge in the middle of the pendulum? Now, you might say, well, it's going to be a bit more complicated, but you'll still be all right. You'll still be able to predict it fairly well. Well, let's have a look, shall we? There is no way I'm going to be able to predict the path of that red light. Even if I tried to release it at exactly the same position, the path is just completely different to last time. Many systems in real life have these, what's called chaotic factors. Tiny little changes become amplified so that you ultimately can't predict the whole system any more than just a tiny, tiny amount of time. And many, many systems in real life are chaotic. This is why we can't predict the weather any more than a few days in advance. Even human decisions could said to have a chaotic element, where tiny differences change the decision completely and everything that's consequent on that decision, like in a footy match where the ball is. So now it's my turn to do a Magnus and have a guess at future technology. I'm not going to do spaceships, I'm not going to do transport, I'm going to talk about houses. This is a really clever architect. His name was Buckminster Fuller. His idea was to use these kind of geodesic domes that are very light and very strong. He thought you could even like plonk them down in a field and get kind of ready-made housing. What he didn't count on was that they're not going to be very comfortable houses. They're basically going to be a nice tent. In order to make a house comfortable, you need all of the infrastructure, right? So when you take a field and you turn it into a street of houses, you've got to dig it up completely to put in the water mains, the sewerage, electricity, gas, telecoms, in order to connect all of that infrastructure to the rest of the infrastructure. That field that might cost a few £1,000s becomes worth £1 million when it gets planning permission, because of all the work that you have to do to make the houses comfortable. Would it be possible to take Buckminster Fuller's idea of just these simple structures but make them much more comfortable? In order to do that, we're going to need new materials. This is carbon, the stuff we're made of. Now, there's several different forms of carbon. If it's in like a tetrahedral structure, that's really, really strong, that's diamond. If it's imperfect layers, that's much weaker, that's graphite, pencil lead. And there are other forms still that we keep discovering. The first new form of carbon was this. It's like a football structure, almost like two geodesic domes put together. So they named it after the guy. It's called Buckminster fullerene. Unfortunately, it's got not that many applications yet. But then these are nanotubes. They do have current applications. They're very thin, strong tubes of carbon. This is aerogel. Now, if you've ever held a piece of aerogel, you can almost feel no weight on your hand at all. And it's an almost perfect insulator. Here we can see a flower that's being protected from a Bunsen flame by the aerogel. And the aerogel is so light that it can actually float on the Bunsen flame. But the biggest miracle of all in terms of a new form of carbon is graphene. Perfect two-dimensional layers of carbon. If you put enough layers together that it was only as thick as cling film, an elephant could stand on a pencil and it still wouldn't go through the film because it is miraculously light and strong. So what can you do with graphene? This is a solar cell, and because it's graphene, it's flexible. So this can take sunlight and turn it into electricity. Then this is a graphene battery. Again, it's flexible. Not only can we turn sunlight into electricity, but we can actually store it as well. You can filter seawater using graphene, or even sewage. At the moment, it's really expensive to filter seawater into fresh water. Graphene massively cuts the energy costs of that. This is called aeroponics. Now, you can grow your own food in the soil, but then the food has to compete with parasites and bacteria and animals and other plants, weeds, and it all becomes a bit inefficient. If you can just have the food itself and you feed it with pressurized water vapor, possibly filtered seawater, it's much, much more efficient, and you don't need all that big an area to be able to feed yourself. So let's think about our structure, right? It's energy independent. It's got a water supply, possibly food supply. All your sewage can be taken care of. What else? Well, if you remember, aerogel is a perfect or almost perfect insulator. That's one of the most difficult things about brick houses, insulating them. Using this stuff on our structure, it can be almost perfectly insulated so we don't waste that energy. Then the structure itself is really thin and light. You could put wheels on it, you could put legs on it so it can climb over stuff or sit on a hillside. It'd float, you could have it underwater. It might even be light and strong enough to float at altitude with a balloon or something. Live in the clouds. So what would I do with this stuff personally? Well, my favourite building in the world is the Arctic Cathedral in Tromsø. If I lived in that building, I think I'd just look through the windows and watch the Northern Lights in one of the most beautiful parts of the world. I'm not really going to be able to afford my own cathedral though, am I? But maybe I don't need to. One other thing that can be done with graphene, in fact it's already been done, is to make flexible screens. Samsung has a phone out right now with a flexible graphene screen. So what could I do with this? Right, if I covered the entire building or structure with screen, I could show the view from behind the building. Kind of makes the building invisible, and it's also incredibly strong, so it's bulletproof. I would have a bulletproof, invisible house. What else could I do with the screens? Indoors, remember Magnus said you've got a wall-sized telly. I could cover walls, floors and ceilings purely with screen, and then I could live wherever I liked virtually. The view outside need not be the actual view. I could actually live in Tromsø virtually and have a perfect Northern Lights show whenever I liked. So I don't actually need my own cathedral. I just need a similar shaped structure, right? Covered in screens inside and out, and solar cells and solar batteries, my own water supply, my own food supply as well. That's the kind of thing I could envisage. These houses really could change the world, I think. To date, what everyone's had to do is work all their lives to afford to live in a brick house. Imagine if one of these things was just a few tens of thousands of pounds rather than like $500,000. You could change the world with this comfortable, sustainable, plonk down housing. So I don't need a full cathedral, I just need that kind of shape with its own food supply. And there's actually one of those down the road from my work. I'd basically be living in a graphene Asda. So there we go, there's my view of the future. Might be completely wrong, whatever. Hope you enjoy all the rest of the events at the festival, and if you want to know any more about graphene, do look it up and research it yourself, or contact us at the Intellectual Property Office.